So, you've seen those slick demos, right? AI agents booking your flights, managing your entire digital life. It looks amazing. But then, why is it that when you try to build one, it feels like it has the memory of a goldfish? Well, today we're going to dive deep into why that happens. And more importantly, we'll look at a new framework that might just give these AI agents the reliable memory they need. Welcome to the hidden layer.
I mean, we've all seen the promise, right? These modern AI agents, powered by large language models, they're supposed to automate all the complex, tedious stuff we do on the web, booking flights, managing content, you name it. The dream is a world where all those boring digital chores just disappear.
But, and this is a big but, if you've actually tried to build one of these things, you know the frustrating reality. You can watch an agent nail a 15-step checkout process perfectly, and then just an hour later, it fails spectacularly on the exact same task. It's like it has total amnesia. So, what is going on here? How can these incredibly powerful AI agents seem so smart one minute and then completely fail at something they've already done? For any engineer working in this space, this is the problem to solve. Figuring out this brittleness is the key to building agents we can actually rely on. So let's break it down. We're going to look at exactly why this happens and explore a new framework that might finally give these agents the memory they so desperately need.
All right, so the core problem here is pretty simple. AI agents are just forgetful. When an agent figures out how to do something complicated, like navigating a specific website's admin panel, it doesn't store that knowledge for later. It's kind of like a chef inventing this amazing, brilliant recipe, and then they just throw it away. The very next time they want to cook that dish, they have to reinvent it from scratch, all over again.
Yeah, and this quote from the research paper really just hits the nail on the head. Every single time that agent has to start over, it's not just slow and inefficient, it's like rolling the dice all over again. Every step is a brand new chance for an error, for a hallucination, and for developers, what does that mean? It means unpredictable behavior and a system you just can't trust with anything important. Okay, so people have tried to fix this, right? The obvious idea is to give agents reusable skills. But most of these attempts have slammed right into a wall, a fundamental problem the paper calls the grounding gap. It's basically a conflict between two different ways of doing things and, well, both of them have a major flaw. And this slide really lays out the two sides of that gap perfectly. So, on one hand, you've got what are called textual workflows. Think of this like giving the agent a recipe in plain English. First, find the search bar, then type in the product name. The agent can understand the steps, but it can't directly do them. It still has to figure out all the low-level clicks and types itself, and that's exactly where the errors creep in. Then, on the other hand, you have code-based skills. Now, these are scripts the agent can actually run, but they're a total black box. The agent just calls the script and hopes for the best. It has no clue what's happening inside. So if something breaks halfway through, the agent is totally lost. It can't adapt, it can't recover. So you see the problem? You get understanding or you get execution. You never get both. And this is where the solution from the paper comes in. It's a framework called WEBXSKILL. And its big idea, its core innovation, is creating a new kind of skill that is both executable and understandable. It finally bridges that grounding gap. So how exactly does WEBXSKILL pull this off? Well, the key isn't just a new type of skill. It's a whole system, a complete three-stage pipeline. It's designed from the ground up to find knowledge, organize it, and then give it back to the agent right when it's needed most. Let's walk through how it works. The whole process breaks down into three clear stages. First up is skill extraction. The system basically watches an agent do its thing and automatically finds these common, reusable sequences of actions, and it turns them into skills. Then, second, you have skill organization. Now, it doesn't just dump all these skills into a big, messy folder. It organizes them into a smart graph that's indexed by the website's URL. What that means is the agent only ever sees skills that are actually relevant to the specific page it's on. Super smart. And then third, skill deployment. This is where the magic really happens, because the framework gives the agent two different, powerful ways to actually use these skills. And this part is where it gets super practical for anyone out there actually building these systems. WEBXSKILL gives you two different ways to deploy these skills. It gives you a choice, really, between full hands-off automation and a more flexible, kind of human-in-the-loop style of autonomy. Okay, check this out. This slide shows the two modes in action, and the difference is really cool. So let's look at the left image first. That's grounded mode. The agent's goal is to post on a forum. It just calls one single skill: submit text post with forum selection.
And boom, the framework executes all 6 steps automatically. It's fast, it's efficient, totally hands-off. Now look at the right image. This is guided mode. Here, the task is to change a shipping address. Instead of one command, the skill gives the agent a step-by-step guide. You can see it gets an instruction like activate the skill, then another one for the address, then the city, and so on. This gives the agent the wiggle room to adapt if, say, the save button is in a different spot this time. It's kind of the difference between a self-driving car on an empty highway versus one trying to navigate a super tricky parking lot. So naturally, this brings up the big question, which mode is actually better in the real world? And what's the secret sauce that makes this whole system reliable in the first place? Well, we're going to show you the data next, and the answer is actually pretty surprising. Let's get into it. All right, here we go. This is the moment of truth. Let's look at the numbers, let's look at the results, and let's uncover the single most important secret ingredient for making a system like this actually work. First up, we've got the Web Arena benchmark. Now, this is a really tough test for web agents. And using WEBXSKILL boosted the task success rate by almost 10 full points over the baseline agent. I mean, that is a huge leap in performance. And it gets even better. On the Web Voyager benchmark, which involves navigating actual live websites, the improvement was even more dramatic, a nearly 13-point jump in the success rate. So the data is pretty clear. Giving agents a memory with these executable skills, it really, really works. But this is where we find that secret sauce. We know it works, but why does it still fail sometimes? This chart is so fascinating. Just look at the 2 biggest slices of the pie, post-skill reasoning and no skill invoked. Together, that's a whopping 74% of all failures. So what does this tell us? It tells us the problem isn't the skills breaking anymore. The new problem is the agent's high-level decision-making. It's either using a skill correctly, but then messing up what comes next, or it's just failing to use a skill that's available at all. The framework is so good, it has literally moved the bottleneck further up the chain to the agent's brain. So listen up, because if you're an engineer, this is probably the most critical takeaway. The single most important part of this whole system is skill validation. The researchers did this test where they just turned off the process of curating and validating the skills, and the success rate absolutely plummeted by over 14 points. So just mining a bunch of skills isn't enough. You have to make sure they're high quality and reliable. That's the key. Okay, so let's bring it all home. What does all of this mean for you, the developer who's out there trying to build a reliable AI agent? Well, the core message is that this framework gives us a real path forward to building more verifiable, more predictable AI systems. So, what are the big lessons for anyone building with AI? First, the future is hybrid. Your skills have to be both executable for reliability, like code, and interpretable for adaptation, like plain text. Second, context is king. Organizing skills in that smart URL-based graph is a total game changer for finding the right tool for the job. Third, you've got to know your model. The research shows that the big, powerful models like GPT-4 do great in that full auto grounded mode, but weaker models really need the step-by-step help of guided mode. And finally, and this is a big one, this points to a brand new priority for engineers. The challenge isn't just about making the agent click the right button anymore. It's about making it think better on a higher level. You know, this really opens up a ton of possibilities. I mean, if an AI agent could truly learn and remember any complex, repetitive task you do on the web, and remember it forever, what's the very first thing you would teach it? I'd love to see what you guys think, so drop your ideas in the comments below. Thanks for joining us on The Hidden Layer.